Hello everyone, and welcome to the Mathematecher channel. Let n be a natural number. Let's put capital A equal n squared plus 3n plus 2, and capital B equal 3n squared plus 15n plus 19. Can you prove that capital A doesn't divide capital B, whatever the value of the natural number n is? Let's see how to do this. At first, we're going to factorize capital A. So capital A, which equals n squared plus 3n plus 2, can be written as equal to n squared plus 2n plus n plus 2. By extracting n as a common factor from the first two terms of this sum, we find that capital A equals n multiplied by n plus 2 plus n plus 2. And now, by extracting n plus 2 as a common factor from the two terms of this sum, we find that capital A equals n plus 2 all multiplied by n plus 1. From this factorization, we deduce that capital A is divisible by n plus 1, whatever the value of the natural number n is. Let's note this as assertion 1. On the other hand, the number, capital B, which equals 3n squared plus 15n plus 19, can be written as equal to 3n squared plus 3n plus 12n plus 12 plus 7. By extracting 3n as a common factor from the first two terms of this sum, and the number 12 as a common factor from the third and fourth terms, we find that capital B equals 3n multiplied by n plus 1 plus 12 multiplied by n plus 1 plus 7. Now by extracting n plus 1 as a common factor from the first two terms of this sum, we find that capital B equals 3n plus 12 all multiplied by n plus 1 plus 7. So we can deduce that, in order for capital B, which equals 3n plus 12 all multiplied by n plus 1 plus 7, to be divisible by n plus 1, the number 7 must be divisible by n plus 1. And this means that n plus 1 has to be equal to 7 or equal to 1, which mean that n equals 6 or n equals 0. Therefore, the only values of n for which capital B would be divisible by n plus 1 are 6 and 0. Let's note this as assertion 2. Now from assertion 2, we can understand that out of the values 0 and 6, whatever the natural number n, capital B isn't divisible by n plus 1. And as assertion 1 affirms that n plus 1 divides capital A, for every natural value of the number n, we can deduce that out of the values 0 and 6, whatever the value of the natural number n, capital A doesn't divide capital B. Now in case n equals 0, we would have capital A equals 2 and capital B equals 19, and as 2 doesn't divide 19, we deduce that in this case capital A doesn't divide capital B. And in case n equals 6, we would have capital A equals 56 and capital B equals 217, and as 56 doesn't divide 217, we deduce that capital A doesn't divide capital B, in this case too. After this, we can finally say that whatever the value of the natural number n is, capital A doesn't divide capital B. As always, thank you for watching the video. We hope you enjoyed it and learned from it. If you are new to the channel, please consider to subscribe, like and share the video, and until the next one, we wish you the best.